Morning. It is Wednesday, March 18th, 2020. I accidentally wrote March 17th on my warm-up video. I apologize for that. Today is Wednesday, the 18th, and we're going to be taking notes on writing equations of exponential functions. So it's all based on that structure of a parent exponential function, which is f of x, or y equals a times b to the x. We know that the a is our initial value, or our initial amount. And we also want to remember that the a always gives us the y-intercept. That if we plug in 0 for x, we'll get back a. So just think, if I plug in 0 here, anything to the 0 power is 1. 1 times a is a. And that makes sense if you think about the phrase initial value. It's telling you when x is 0, you're going to get back your a, your initial value. So those two things kind of make sense together. The b represents our growth or decay factor. And we know that if b is greater than 1, it's showing us growth. And if b is between 0 and 1, it's showing decay. b is never negative, it's never less than 0. Okay, so first thing we're going to practice is writing equations of exponential functions given information. So let's call this example 1. And we're asked to write the equation of the exponential function passing through the points 0, 5, and 115. Okay, so I always start by organizing my thoughts into a table. It just kind of helps me think about this stuff a little bit better. When x is 0, y is 5, and when x is 1, y is 15. And the first thing I notice is they actually give us the y-intercept. When x is 0, y is 5. We also know that the y-intercept is the same as the initial value. So they're giving us the a here. When x is 0, y is a. So my function is going to be y equals 5, my initial value, times b to the x power. The x is always the exponent. That's the definition of an exponential function, that your input is the exponent. We just have to figure out what our b is. So I look over at my table and I try to figure out what's happening here. And I see that as x increases, y also increases. It starts at 5 and then grows to 15. So this is depicting a growth function. We just have to figure out how fast is it growing. And I can see that I went from 5 to 15, meaning my amount tripled. It multiplied by 3. So my function is going to be f of x equals 5 times 3 to the x power. And you can always double check by plugging in a value here. Let's plug in x for 1. 3 to the first power is 3. 3 times 5 is 15, so it works. As far as function notation or y notation, these are synonymous. It's up to you which you prefer. Sometimes using f of x is beneficial, sometimes using y is beneficial. It just depends on the context of the problem. Okay, example 2. This time we are asking to write the equation of the exponential function through the points 0, 12, and 1, 3. 0, 12, and 1, 3. Okay, so I'm still going to make a table here. It's just kind of how my brain organizes these things. Once again, they have given us the y-intercept, also known as the initial value. So I can assume a is 12. Y equals 12 times something to the x power. We just need to figure out our b, our growth or decay. So in this case, as x is increasing, y is decreasing. It starts from 12 and then gets smaller down to 3. So this is depicting decay. And we have to figure out how fast is it decaying. So we can see that to get from 12 to 3, they obviously divided by 4. But the structure of an exponential equation is always written as multiplication. It's always a times b. So I can't write divide by 4. I have to think about how to write divide by 4 as multiplying by something. And if you think about your fractions, dividing by 4 is the same as multiplying by the reciprocal, 1/4. So if I plug in x for 1 here, 1/4 to the 1 is 1/4. 12 times 1/4, or 12 divided by 4, is 3. So there's my function, y equals 12 times 1/4 to the x power. Okay, we actually have 3 more examples. I know this video is a little longer than usual, but I have to cover my bases and show you all the different ways that these types of problems can manifest. So moving right along, example 3. This time we're writing the exponential function through the points 212 and 324. Okay, so I'm still going to make my table, but I'm going to give myself a little space at the beginning here and start my points 212 and 324 at the bottom. And then I'm just going to think logically to fill out the rest of my table. They have not given us the initial value in this case. They haven't given us the y-intercept, so I have to start by figuring out what that is. I notice, thinking backwards, that as x's decrease by 1, y's decrease by half. 24 divided by 2 is 12. So I'm going to divide by 2 again to get 6, and divide by 2 again to get 3. So my initial value here, when x is 0, y is 3, is going to give me my a. So I thought backwards to fill in my table, but now I'm going to think frontwards in order to figure out what my growth factor is. As x's increase, y's also increase. So this is a growth problem. And to figure out how fast something is growing, I see that each of these values is being multiplied by 2. It's doubling. So there's my exponential equation, y equals 3 times 2 to the x. You can always plug it in to see. Let's say if x is 2, 2 squared is 4, 4 times 3 is 12. I did my work right. There's my equation. Okay, I got 2 more of these. They do get tougher, so stick with me. Example 4. We're going to write the equation of an exponential function through 0, 3, and 421. Okay, 0, 3, and 421. So in this case, they have given us our initial value, 0, 3, and then they've given us another value that's quite a ways apart from that initial value, 21. So instead of thinking logically, trying to figure out how fast this thing is growing, I'm actually going to use algebra in this case. So first off, I know that my initial value is 3, that's given to me. They also give me a second set of points here. They give me a x value and a y value. I'm going to plug in the x and the y value and solve for my b algebraically. So in this case, y is 21 and x is 4. Now I have enough information to solve for b. So think order of operations, start by dividing both sides by 3. 7 equals b to the 4th. And then to cancel out a 4th power, I have to use a 4th root. Okay, so when I plug that into my calculator here, just a reminder, to access your 4th root, you're going to enter 4 first, then come up to the math button, scroll down to option 5, which says x root. Your calculator automatically substitutes x for 4 here, and we're going to take the 4th root of 7, which is 1.62, blah, 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 blah. Let's see, does that convert to a fraction? It does not. So we're just going to have to round our decimal here. 1.626, I'm going to round that to 1.63. In general, 2 decimal places is enough. Okay, so my function is going to be y equals 3 times 1.63 to the x power. And just out of curiosity, I'm going to plug in a point here and see how close I get, even though I rounded my growth factor. So I'm going to plug in x for 4. 3 times 1.63 to the 4th power is 21.2, essentially. So pretty close to 21. The more decimal places you use, the more accurate your growth factor is going to be. But in this case, I think that's close enough. Okay, number 5. Last one. Writing the exponential equation through the points 0, 81, and 3, 3. Okay, so they're giving us our initial value. The next point that they give us is pretty far apart. So instead of filling in the table, I'm once again going to use the algebra method. So I know that my equation is going to be y equals 81 times b to the x. They give us the initial value here. And then I'm going to use my second point to plug in my values and solve for b. So y is 3 and x is 3. Okay, I'm going to divide both sides by 81 here. Okay, that's going to give me 3 over 81. I'm not going to round. You're going to see why in a second. And then to solve for b, I have to take the cubed root of both sides. Cubed root cancels out a cube. And I'm going to find the cube root of this entire fraction. I'm going to delay that rounding. The further you delay the rounding, the more accurate your answer is going to be. So as a reminder, your cubed root button is located in the math menu down to number 4. And we're going to find the cube root of 3 over 81. I'm going to close my parentheses around the 381 to show that we're taking the cube root of that entire fraction here. This is why I didn't round. 0.333333 repetit is 1/3. So instead of rounding the decimal, I'm going to be as accurate as possible and show that my my decay rate is 1/3. Okay, so here's my function. Y equals initial value 81, decay rate 1/3 raised to the x value. And to double check your work here, you can plug in that 3 to the 3rd power, or 3. 81 times 1/3 to the 3rd power is exactly 3, and that's what we want here. If I had rounded to a decimal, it would have given me something different. So the reason I'm pointing out these two problems here, sometimes you're going to have to round. The 4th root of 7 does not simplify to any fraction. You could leave the entire growth rate 4th root of 7, which is kind of clunky, but in this case, I was able to get a nice even fraction here, which is going to be far more accurate than if I had rounded to 0.34, for example. Okay, that's it for your notes. Your homework for today is page 2 and 3 out of your packet. It says writing exponential functions day 2 notes at the top, and you're doing everything through example 4 on page 3. Solutions are up online, and as always, please reach out if you have any questions. We can schedule a Skype call, we could talk on the phone, whatever you guys want, I'm here for you. Good luck.